Good day to our lecturers and fellow classmates. We are Group 1 from Class ECG563 6A2A presenting our road safety audit for critical vertical curve along Persiaran Institute UiTM Shah Alam. This location was selected due to several safety concerns, including limited stopping sign distance caused by the hill crease, increased vehicle speed when decreasing the slope, and potential conflict between vehicle and pedestrian. Although the pedestrian walkway is available, there are no designated road crossing marking to ensure safety crossing. Therefore, this study aims to improve road safety while supporting sustainable development goal 9 and 11 by promoting safer and more sustainable campus infrastructure.
To investigate the operating speeds of vehicles at the study location, our group conducted a spot speed study using a digital laser speed gun.
Before beginning the survey, we arrived at the site approximately 30 minutes early to conduct a preliminary site inspection. During this time, we assessed the road environment, selected a safe and suitable observation point, recorded the weather conditions, and completed the general information on our data collection forms. Controlled distance served as our study zone, ensuring we could accurately track and evaluate vehicle operating speeds. We utilized a rolling measuring wheel to map out and establish a precise 100-meter target baseline distance down the slope approach. We checked that all equipment, including the laser speed gun, clipboards, data recording sheets, pens, and backup batteries, was in good working condition. Throughout the survey, every team member wore a high-visibility safety vest to improve safety while working near live traffic. To ensure that the recorded speeds reflected normal driving behavior, the observers and the laser speed gun were positioned as inconspicuously as possible. The laser gun was carefully aimed at approaching vehicles to obtain accurate speed measurements without influencing driver behavior.
We collected the speed data of 100 vehicles using laser speed gun. Lowest recorded speed was 16 km per hour, while the highest speed was 48 km per hour. The average speed was about 30.34 km per hour. From the table, 48% of vehicles travel between 30 and 39 km per hour, which is the highest percentage. Another 42% travel between 20 and 29 km per hour. This means that most drivers travel at a moderate and steady speed. However, even though the average speed was not very high, there are still safety concerns at this location because our site observation found illegal pedestrian crossing, limited traffic signs, dim street lighting, and blind spots. This issue can reduce driver awareness and increase the risk of accidents, especially during busy traffic or at night. From the histogram, the most common speed or model speed was 34.5 km per hour. The cumulative graph showed that 85 percentile speed was 34 km per hour. This means that 85% of the vehicles travel at or below 34 km per hour. This result shows that most drivers were not speeding. However, speed is not the only factor that affects road safety. Because there are blind spots and poor street lighting, drivers may not be able to see pedestrians clearly, especially those using illegal crossing points. In addition, the lack of traffic signs may make drivers less aware of possible hazards. Therefore, although the traffic speed was generally safe, these road conditions still create safety risks for both drivers and pedestrians.
Based on our engineering evaluation, this location presents a significant pedestrian safety concern. Although the posted speed limit is 30 km per hour, our speed study recorded an 85% height speed of 34 km per hour, indicating that the majority of drivers are traveling above the intended operating speed as they descend this hill. The existing pedestrian walkway naturally channels students to cross at the bottom of the downhill section, creating a clear pedestrian desire line and a high conflict zone between vehicles and pedestrians. However, there is currently no designated pedestrian crossing at this location. Considering the excessive operating speed and frequent pedestrian movement, a raised pedestrian crossing should be introduced. In accordance with JKR Road Safety Principle, additional traffic control measures should also be implemented. Since this location consists of a downhill vertical curve with pedestrian activity, advanced warning signs together with clearly visible 30 km per hour speed limit signs should be installed to alert approaching drivers and reinforce speed compliance. Our audit also identified the absence of a roadside protection. Bullet should be installed along the pedestrian walkway to create a physical barrier between pedestrian and moving vehicles, reducing the risk of severe injuries if the vehicle leaves the carriageway. Overall, the combination of a raised pedestrian crossing, enhanced warning signage, and roadside bullet would reduce vehicle speeds, increase driver awareness, and significantly improve pedestrian safety along this section of road.
Based on the audit, we found that there are various issues related to the roads being studied. So, we proposed a few mitigation controls based on JKR guidelines. For the first issue, we recognize lots of students been crossing at the area, but there isn't any crossing there, making it illegal and dangerous. The existing warning signs cannot alter human habits or clear a structural geometric obstruction. So, to alter this problem, we propose to construct a raised pedestrian crossing. Because the blind spot heavily restricts a driver's available sight distance, we must physically alter the road profile to slow down oncoming vehicles. By constructing a raised pedestrian crossing directly at the College Melati shortcut path, we force at least 80% of speeding vehicles to drop below 30 km per hour, neutralizing their downhill grade momentum and ensuring they can stop instantly if a student steps out. Students also can reach their faculty early rather than go to another far crossing. We also propose installing pedestrian guardrails and perimeter fencing to guide pedestrians toward the designated crossing and discourage unsafe crossing at random locations. In addition, more roadside safety bollards should be installed to protect pedestrians from vehicles that may lose control while traveling downhill. Next, to solve a geometric blind spot, drivers must be warned before they lose their line of sight. We also note that the area didn't have a lot of road signage. So, we propose installing JKR standard warning signs such as blind crest ahead and pedestrian crossing ahead warning signs, equipped with solar flashing amber beacons at least 50 meters before the peak of the hill. Additionally, advisory speed limit signage, for example slow 30 km per hour, should be installed to further alert road users. This tactical placement forces oncoming vehicles to react and decelerate before entering the blind shadow zone. Lastly, to improve visibility during nighttime, we recommend upgrading the existing streetlights to high luminance LED lighting with illumination focused on both the hill crest and the pedestrian crossing area. This will improve drivers' visibility as they approach the blind crest, making pedestrians and potential hazards easier to detect earlier. It also enhances overall road safety while providing a more energy-efficient and cost-effective lighting solution. In conclusion, our road safety audit identified several critical safety issues, including illegal pedestrian crossings, limited sight distance caused by the hill crest, inadequate traffic signage, and poor nighttime visibility. To address these risks, we propose a combination of engineering measures based on JKR guidelines, including a raised pedestrian crossing, pedestrian guardrails, additional safety bollards, advanced warning signage with flashing beacons, advisory speed limits, and upgraded LED street lighting. This improvement work together to reduce vehicle speeds, improve driver awareness, guide pedestrians to safer crossing points, and enhance visibility during both day and night. More importantly, they create a safer environment for all road users, especially students who use this route daily. Overall, our proposed solution supports Sustainable Development Goal 9 by promoting safer and more resilient infrastructure and SDG 11 by creating a safer, more inclusive and sustainable campus for the entire UiTM community.